So, good morning, dear students. So, today we are going to discuss about two topics on fluid mechanics. So, mainly we'll be focusing on the Pascal's law. So, before that, we can see a small introduction to the fluid mechanics topic, which already have been discovered or covered in the previous sessions. So, pressure and its measurement. So, what is pressure and how we are going to measure the pressure using what type of instruments we can measure the pressure and how, what type of calculations we can use. Okay, so based on that, there are some derivations, small concepts like Pascal's law, hydrostatic law, and today we are going to explain about the Pascal's law and what does it mean and how the mathematically we can prove Pascal's law. And here you can see a pond where the fluid is static. So whenever there is a movement or motion, then we will call it as dynamic. On the left side, there is a static fluid, and right side there is a dynamic fluid because there is flow happening. So in this right hand side, on the dynamic side, also there again you can differentiate into uniform, non-uniform, steady, unsteady. So what is the difference between steady and unsteady? The basic difference is nothing but if it depends upon time. If it depends upon time, parameter which depends on time means that is an unsteady parameter. For example, velocity. With respect to time, if we are focusing on one point and if we are measuring the velocity at two different times and if we are getting a variation in the value, then that is a transient flow, that is unsteady flow. With respect to time, the velocity is varying. And if you are measuring at two different times and you are getting the same velocity, then that is a steady flow because velocity flow is happening, but steady flow because velocity is not changing with respect to time. And what is it then uniform, non-uniform? Uniform flow means everywhere the same velocity. Okay. A non-uniform flow means the velocity will vary with respect to space or with respect to length or with respect to distance. Okay, so whichever parameter, if you are measuring at x1, point x1, and you are measuring at point x2, there is a change in velocity, then that is non-uniform flow. Since the velocities are different with respect to space or distance or coordinate or time. So not time, not time. Time is depending only on time will come in steady and steady. Okay. Here, uniform, non-uniform means space only will consider. It can vary with time also. But then unsteady, non-uniform flow, unsteady, steady flow. Yeah, steady flow. Okay, so that kind of combinations will come. So unsteady, so what does that mean? So flow, everybody is flowing, but with respect to time, there is no change in the velocity in that particular point, then that is steady flow. But with respect to space, where the velocity is changing, then that is a non-uniform flow. That is an example of steady non-uniform flow. Both two points, with respect to time, there is no change, but with respect to length, the velocity is different. So steady non-uniform flow. So like that, different combinations we can generate. Okay, fine. So we are going to next slide where we are explaining the content which we are going to cover in this particular module. Okay. And here in this particular lecture video, we are going to cover only Pascal's law. So first one, what they are mentioned, the pressure measurement. So we need to be very thorough with the Pascal's law. Then what are the different types of pressure measuring devices, piezometer, manometer. Then what is difference between atmospheric absolute gauge and negative pressure. Then next time, the other side, it will be buoyancy force and what is the significance of meta center and then what we term called equilibrium in buoyancy. Yes, today we will deal with Pascal. Okay. So pressure, what is pressure? Pressure we can define as a ratio of force to area. Okay. Uh, normal expression only and unit it can be kgf per meter square, kgf per centimeter square or Newton per meter square or Newton per millimeter square, and also we know 1 Pascal is equal to 1 Newton per meter square. Okay. So here what we are going to do is that we will consider a small wedge fluid element. This is a fluid element of wedge size. Okay. And what is the pressure exerting normal to this particular area? That is PZ is the pressure normal to the surface. Pressure is always acting normal to the surface. Okay. There will not be any inclined component of pressure. Pressure always acts normal to surface and only one component, that is that normal component. Okay. And here on the PX side, right, left hand side, you can experience the PX acting on the side AB, and there is a PY which is acting on the surface AC. So what is the width of this wedge? It is, we will assume the width as 1 unit. Okay. So accordingly, we have to calculate the area, and then we will find the force. So if we know the pressure, we can calculate the force. How we can calculate force? Force is pressure is acting per unit area, then pressure is force into that area, total force acting per unit area into that total area will give you the total force, okay, acting on that particular area. Now we can see what is the length of this BC, DS, what is the length of AC, DX, length of AB, DY. So keeping this in mind, we will explain. Go to the next slide. That is the then force acting on the element are pressure force normal to the surface and weight of the element in the vertical direction. These are the two forces acting on the wedge element. So face on the forces on the face AB is pressure into area of that face AB. What is the area of the face AB? Length into width. So what is the width? The length is dy, width is 1. So px into dy into 1 you will get. And what is the force acting on the AC? Then py. Similarly, py into dx into 1. And phase BC, that is pz into ds into 1. So what is the weight of the element? The weight of the element, how we can calculate from the specific gravity. Okay. So see what is specific gravity? Density into rho into g. Density into acceleration due to gravity. The specific, not specific, not specific gravity, specific weight. Okay, we can calculate total weight from specific weight. Specific weight is the weight acting per unit volume. So if you know the total volume, then if you multiply specific weight with the total volume, then you will get the weight of the element. So that is this is specific weight, weight acting per unit volume into volume of the wedge. Volume of the wedge is calculated from the base area. What is half BH? Half into base is dx into dy, or AB into AC, or AC into AB, and into width is 1, that is volume. Then this all time will be 1 unit volume, and into the specific weight you will get the weight of the element. Now, next is what resolving forces in the x direction. We have px dot dy into 1 minus pz dot dx into 1 into sine 90 minus theta minus 0, because we are resolving this particular thing into vertical 1 and horizontal 1. So if you consider the forces in the net forces in the x direction, here comes the positive x direction and here comes the negative x direction. That is the minus coming here. And accordingly, if you use the trigonometric function, then we can modify it into px dy into 1 minus pz is 1 cos theta. That is sin 90 minus theta is cos theta all is equal to 0. Now, if you calculate ds cos theta, that is nothing but ab or dy. We will substitute ds cos theta is dy here. Then next what we will get, so we will be having is see one. Yes, we will be having that dx into dy minus dz into dy is equal to 0. From that, we can get dx equal to pz. That means dx equal to pz, same pressure. Even if the area is length is different, the pressure acting on that particular point will be same. Dx equal to pz. Similarly, next in the next slide also we can write similarly resolving force in the y direction. We can write py dy, sorry, py into dx into 1 minus pz ds into 1 cos 90 minus theta minus dx dy by 2 into 1 into w, or specific weight equal to 0. Why we are additional term? Because it's, apart from the px and p, that there will be a weight component acting downward, but in the later stage we will consider it as negligible and we will move forward. So next is so if we consider then the trigonometric relations here, then we can get that cos 90 minus theta is sin theta, and ds sin theta is nothing but dx. And also the element is very small, hence weight is negligible. How we are neglecting the weight? Because since it is of dx, very infinitely small element, means weight will be very small compared to the pressure acting on that particular side. Okay, so we will neglect the weight, then we will get another expression called dx minus pz dx equal to 0. Then what we will get, then from that equation py equal to pz we can get. Then further what we can say, finally can see it is px py pz equal to 0. That is called Pascal's law. So this is Pascal's law. Okay, thank you.